Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is construct a BST from pre-order traversal. Okay, so in this question we have been given an array of pre-order traversal, and with the help of this array we have to construct a BST. Okay, what is BST? BST is actually the binary search tree. Okay, so we already know all these things. So now we have to construct the BST from the pre-order traversal. So let's go and see how we can do this. Okay, so this is our pre-order traversal. Pre-order. Okay, now like while doing this question you need to know something about pre-order traversal. So what is this thing? So when we start traversing the pre-order now, so the first node which we get is the root node. So the first node is always the root node. Okay, this we already know. So when we start traversing, we always give the call of left side. We always move the left side. Okay, so first we go for left side. So there is 20 and there is also 20. Then again we go move toward the left side and there is 10. See, there is also 10. And then what happened is, now again we start going to left side, but there is no element to the left side. So if there is no element to the left side, then what we do? If there is no element to the left side, then we start moving to the right side. Okay, then we move to the right side. And suppose if there is no element to the right side also, okay, suppose there is also no element to the left side and right side also, then what happens? Then we backtrack. And if there is element in the right side, then what we do? Again we move toward the left and right. Okay, so let's see the movement here. So how we traverse? First what we do? We move toward left side, again left side, again left side, but there is no element to the left. So what we do? We move to the right side. Okay, then again we move to the left, there is no element. Then we move to the right, there is also no element. Then what we do? If both is null, that is if there is no element towards the left side also and there is no element towards the right side also, then what we do? We just backtrack. Then we go move upside and there is no path remaining. Like we have also used left path and also used the right path. Then again we backtrack, we go up, and now what we do? We explore some more path. Like we have already traversed to the left side. Then what we will do? We will move toward the right side. Okay, so again we will move toward left side, again left, there is no element toward left. Again we move toward right and there's no element toward right. Then again what we do? We just backtrack. And then what we do? Right side, there's no element toward right, so again we backtrack and all the paths are explored. Then we move up and then right, left, again move left, no element, move up, again right, left, right, no element, backtrack. This is the behavior of traversal. So the first thing which we know is, we know that first what we have to do? We have to move. Okay, so let's understand the behavior, like how we are going to call it. Okay, so first what we do? We move towards left. Okay, first we move toward left, and if left is not present, then what we do? We move toward right. Okay, then suppose right is present, then again what we do? We move toward left, then right. And the third thing is, if left and right both are not present, then what we do? We just backtrack. Okay, so this is the behavior of the pre-order traversal. So what we are going to do is, we are going to use the left call first, then I'm going to use the right call. Okay, and then again we are going to use the left call. So if there's no element, then what we will do? We will just return it. Okay, So see how we are going to approach this problem. So first what I will do is I'm going to take one IDX, that is one variable which will point towards the first element of the array IDX. Okay, so I'm going to use this variable, then it will always point to the first element. Okay, now I'm going to place this element to the right position. Okay, then I'm going to move towards forward, like IDX will increase when you create this node. Then what I will do is I will increase the IDX. That means now we are going to place this 20 somewhere in the tree. Okay, then again I will place 10, then again I will place 15, then 25. So this way I'm going to place the node one by one. Okay, so what I will do, I will create a node. Okay, so the first step is we have to create a node. Okay, so first step is we have to create a node. Okay, and second step is first we use the left call, then we use the right call. Okay, now as we are creating the BST tree, this is a binary search tree. Okay, so this is BST tree. What is the functionality of BST tree? That is range. So this is the most important thing in this question, that we need to take care of the range. Like for example, BST tree is, suppose this is the root node. The range of this node is the left side, all the element towards the left side are smaller than 30. That means the range will be minus infinity to 30. Okay, you can see all the element lie in this range, within this range, like all the element is smaller than 30. Okay, and what is the range of right side? The right side range is 30 to infinity. So all the elements are greater than 30. So this is the range which we need to take care. So what I will do is I'm going to, we already know the first node is root node. First I'm going to create a root node, that is 30. We have created it. Now what I'm going to do is I'm going to specify the range. Okay, so first in the starting what I will do is I'm going to call the function, and the range what in which we will pass is minus infinity to infinity. That means the root node can be lie with in this range. Okay, so this is the starting index. So this is the left range and this is the right range. Okay, so now we are going to construct the root node. So I will read the IDX value, that is 30. So 30 is within this range, so I am going to create a root node. Now after creating this node, I am going to increase the IDX. Now IDX will be this. Now what I have to do is I have to place 20. I have to place this node. And what is the range? So let me write the range also. So range will be minus infinity to 30. Okay, the left range is minus infinity to 30. And what is the right range? Right range lie between 30 to infinity. Okay, so all the elements are greater than 30 and all the elements are less than 30. This is the left and right range. So now we have to place 20. Okay, so then what I will do is I'm going to check for the left first. Okay, so is 20 lie in this range? Yes, it lie in this range. So what I'm going to do is I'm going to create 20. Okay, so I will create 20 and attach towards the left side. Okay, so what I will do, I will create a 20, a node, and I'm going to attach with the left side of the node. Okay, because this node lies in this range. Okay, so that's why I'm creating it towards the left side. Okay, then again what I will do, I will increase the IDX by 1. Now the element is 10. Okay, now I'm going to fit this element, this node, sorry. So again, what will be the range? So each and every time we have to find we have to attach the range. So what is the range for this? The range for this is minus infinity to 20. Okay, because all the element which are smaller than minus 20 will be lie in this side, in the left side. What is the range for this? This is important actually. The range for right side is 22. these elements are greater than 20 but smaller than 30, because overall we have to maintain the thing, that is this range. All the elements should be smaller than 30. So this range will be greater than 20 but smaller than 30. Okay, 20 to 30. Okay, so this is the right side call. Okay, so now the next element is 10. So does 10 lies in this range? Yes, it lies. So what we will do, we will attach the 10 towards the left side. Okay, because this element lie within this range, that is minus infinity to 20, which is smaller than 20. Okay, so now we have also fixed this. Now we are going to fix this. So again, I'm going to specify the range. So what will be the range? The range will be the minus infinity to 10. And what will be the range for this side? All the element will be the smaller than 20 and greater than 10. 10 and 20. Okay, so this is how we are going to create the range. Now we are going to increase the IDX. Now the IDX will become 15. So will 15 lie there? No, because 50 is not in this range. So now from this condition you can able to understand what is the base condition. What is the base condition? If the array of IDX is greater than the R. Okay, or else you can also say that if array of IDX is less than this range. Okay, left side left range is greater than the array of IDX. We will understand it why this is a base condition. Okay, later on when we are doing the coding part. So now we have to fit the 15. So 15 will not lie in this range. Okay, so we will check for this range also. So does 15 lies in this range? Yes, it is between this range. So 15 will come here. Okay, so like this way we are going to attach each and every node within their correct place. Okay guys, so let's go and code this. So we have to code this program in C++. So now we are going to start coding. So first what I will do is I'm going to create one more method. So I'm going to create one more method with the name of, I'm going to change the name, construct bst. Okay, so this is the name, construct bst, and then I'm going to call it here construct bst. So let me copy this and let me call this here. So first I'm going to pass the pre-order, and two more things we have to pass. See, now we need to figure out what the two things which we need to pass. We have to pass the range. See, these range we have to pass. What are these range? The first one is left range and the right range. Okay, so we have to pass the left range and the right range. So what is the left range in the starting? In the starting we have passed the minus infinity to infinity. That means the number can be lie between within this range only. Okay, so after that we have to change it, like when we call the left side and right side. Okay, so minus infinity, how can we write this? Minus int 1e8, that is minus infinity. So here it is. And what is plus infinity? Plus infinity is the this one 1e8 only. Okay, so let me receive it here also. That is the left range. The second one is the right range. Okay, let me change this name. Let me write it with ARR. Okay, so we have received the one array and left range and right range. Now what we have to do? We have to create one IDX. Okay, so we have to create one IDX, and then what I will do is I'm going to create the node each and every time. Then I'm going to check with the range, and then we are going to place it to the left side or else the right side. Okay, the first step is we have to create the variable int idx. Okay, and I will start with 0. Then what we have to do, we already know like this is the root node. So what I will do is I will initialize the node to the root node. Okay, so each and every time what I will do, I'm going to create a node. Okay, like first I've created this, then again what I have done is I will create this, so 20, and we have to attach with the left side or else the right side. So according to the range we are going to attach this these nodes. Okay, so first step is, so let me write it somewhere else. So first step is create the node. Create the node, and we will check the range. Like according to the range, we have to initialize with the left or the right. Okay. So let me do this. So let me create the node. So tree node, star node. How we can create the tree node? Like this. We are going to create the object for the pointer. And what is the value? Value will be the array of idx. Okay, so array of idx, and each and every time I have to increment the idx by 1. Okay, so by this line we have created the node, okay, so now we have created a node. Now what I will do is I'm going to give the calls, left call as well as the right call. Okay, so in which we have to decide the range also. So let me give the two calls, that is construct pst, and that is the left call. Where is our method? This okay, so in which we have to pass the array and left range and right range. Now you need to figure out what is the left range and what is the right range. See, in this case, what is the left range? Left range is same as the left range. Okay, the left range is equal to the left range only. And what is the right range? Right range is equal to the, this is node. Right range is equal to the node dot well. Okay, so I'm going to specify it. Left range is equal to left range only, and what is the right range? Right range is node of well. Okay, and this is our right call. If the element lies within this range, so I'm going to attach to the node of left side. So I'm going to attach it to the left side of the node. Okay, the same thing we have to do for the right also. So I'm going to change the name only. And what is the left range and right range of the call? This one. See, the right range is equal to the right range only. Okay, so right range is not changing. The only changing thing is this LR, and that is equal to the node dot well. Okay, that is 30. Okay, so let's change this. What is the left range? Node of well. And what is right range? Right range will equal to the right range only. Okay, so we have also used the calls. Now in the end we have to return the node. Okay, so we have returned the node, and the last thing which we have to do is we have to handle the base case. Okay, so what is the base case? So we need to figure out the base case. So the first base case is if we have completed the traversal, then we have to return. So let me write this first base case. Okay, so if idx, if the value of idx is equal to the array of size, then in that case we have to return. And what? Return null ptr. Okay, and what is the second base case? See, this is, let me see for this range. This is our minus infinity 30. Okay, suppose array of idx is, this is lr, this is r. Suppose array of idx is somewhere this side. Okay, then what we have to do, we have to return. And suppose this is after the right range. Okay, if this is this side, and if the array of idx is towards the left side, and it does not specify within this range, then what we have to do? Then in that case we have to return the null. Okay, so if the node does not specify within this range, then in that case we have to return it. Okay, so we have to only mention these two conditions. So if array of idx is smaller than the left range, that means this side. If array of idx is smaller than the left range, then we have to return it. Or we can also say that if array of idx is greater than the right range. Okay, if it is greater than the right range, then also we have to return it. Okay, so let me specify this also. Array of idx is greater than right range, then we have to return the null. Okay, so let's run this and check for the compile time errors. So it is accepted. So let me submit this and check for the test cases. So all the test cases are running fine. Okay, so thank you guys for watching this video, and we'll meet you in the next video.